Hi everyone, welcome to the Intro to USD Workflow series. In this series, you'll learn the basics of the USD workflow, including USD composition, assembly, caching animation, as well as lighting. In this first tutorial of the series, I'll give an overview of prim hierarchy and variance sets. If you aren't familiar with USD terms, I recommend reading the USD terminology and composition page in Maya USD Online Help before watching this tutorial. I've included the link in the description. Without further ado, let's dive right in. To demonstrate USD structure, I prepared a USD file of this arcade machine. The original models of all the assets used here were created by Kitbash 3D. There are different ways to structure a USD object. The structure I'm going to show is similar to what the Academy Software Foundation recommends. To load a USD file, go to the USD Layer Editor, select Create Stage From File, and select the file that you want to load. If you don't see the USD Layer Editor in the UI, you can find it under Windows in the main menu. Now we see the arcade machine in the viewport. And in the layer editor, we see the layer that contains the arcade machine. Usually, each layer is saved as a USD file on disk. In this case, the geometry and material of the arcade machine are written in the same file, which is why we only have one layer here. I'll talk more about USD layers in the next tutorial. You may have noticed that the file extension is .usda. The difference between .usda and .usd is that .usda is readable. You can open the file and edit it. While .usd is binary, it's not human readable, but it's much faster to process. Now I'm going to turn on the texture view so we can see the materials. In the outliner, if I expand the tree, you see the hierarchy of the prims. There are different types of prims. At the top level is the root prim, which has the type XForm. XForm acts as a container with transform data, which can be used to translate, rotate, and scale the prims contained within it. This root prim has two children, Geo and MTL, representing geometry and material respectively. The type of these two prims is scope, which serves as a container for grouping other prims without applying any transformation. The prim Geo has two children, proxy and render, which are also scope. Proxy and render refers to the purpose for rendering the prims. Proxy contains low-resolution geometries, while render contains their high-resolution counterparts. If I expand proxy and render, you see the prims they contain. The type of these two prims is mesh. In our case, the arcade machine was modeled as one single mesh, so there's only one mesh for each of them. The child of proxy is a low-res mesh, while the child of render is a high-res mesh. Right now, the render purpose is set to proxy. That's why what we see in the viewport is a low-res mesh. We can easily switch between render purposes in the attribute editor. Inside the proxy shape panel, under Stage Display, we see there are three options for purpose. I'm going to uncheck proxy and check render. Now we see a high-resolution model in the viewport. In USD, you can also define a subset of geometry using geom subset. For example, if I expand the mesh, all these elements are geom subsets. Geom subset allows you to specify a group of faces, vertices, or edges within the mesh prim. This makes it easy for material assignment. For example, this geom subset is the part of the mesh that makes the screen. Inside the material scope, we see a shader of the same name, which is assigned to the screen. As I mentioned earlier, an XForm prim allows transformation to be applied to its child prims. Here's how we can translate, rotate, and scale the arcade machine. Select the root prim. In the attribute editor, we see that its type is XForm. You can just get the manipulator and translate it in the same way as translating a Maya geometry. Similarly, you can rotate and scale it. To save the edits, you can just double-click and select Save. Now we've seen a typical structure of a USD object. Let's move on to see what a variant set looks like. I'm going to hide this arcade machine and load a new USD file that contains a variant set of arcade machines. At the moment, it looks the same as the file we opened before. If I expand the tree, it has the same structure as the previous one. But if I zoom in, you'll see here at the corner of the icon, there's the letter V, which the previous one doesn't have. This letter V indicates this prim is a variant set. If I right-click, go to Variant Set, you see there's a variant set named Arcade Machine, which has 5 variants. We can easily switch between the variants here. You may have noticed that the first variant isn't located at the origin like the other ones. That's because this variant references the first arcade machine we loaded, where we applied transformations and saved the change. If I modify the reference, the variant will update accordingly. Let's see how to do it. I'm going to hide this for a moment and show the previous arcade machine that the variant references. Select the root prim and go to the attribute editor. Here I'm going to reset the translate, rotate, and scale parameters back to their original values, and save the Maya file. If a Maya file contains a USD stage with edits, you'll see this dialog asking whether you want to save the Maya file or the USD file or both. I'm going to save both. Let's hide this arcade machine and show the one with the variant set. You can see that the transformation of this variant is updated. Now I want to briefly show the USD file. Here it defines the variant set, which has the name arcade machine. It has 5 variants, A, B, C, D, and E. Each variant references one USD asset as a payload. Payload means you can load and unload the reference. I'll show more examples of USD references and payloads in the next tutorial. Another feature I want to mention is reload. You can find it in the context menu. This feature lets you reload a USD file. For example, if I remove the last variant and save the file, after I reload the file, you'll see now the variant set has only 4 variants. This feature is useful when different artists are working on the same project simultaneously. You can always see the most updated scene by simply reloading the layers other artists are working on. That's it for today. In the next tutorial, I'll show you how to assemble a scene in USD. Thanks for watching. Stay tuned. I'll see you next time.